Well, hello, my algebros. I'm going to go over the 1-6 homework. And so it was this half sheet, 10 problems solving for a variable. And notice at the very top, it says you have to show your work on a separate sheet of paper. If you fit it on here, that's great. But if not, you need to show it on a separate sheet of paper. But I'm going to go through this with you so that you have some help. So, okay, just to kind of review really quickly here, we have been looking at what PEMDAS means. And PEMDAS is our orders of operations when we are evaluating an expression. When we evaluate an expression. And to be clear, an expression is just one half of an equation, right? One half of an equation. An equation, when we are solving equations, we do the opposite of PEMDAS, right? I mean, of course, we have to check and make sure if there's an evaluation that needs to happen first on one side of an equation, like on number 5. We'll get to that in a second. But after that, when we solve, we do the opposite, or we SAD map. We first see if there is something that we could subtract or add, divide, or multiply. And then we look at our exponentials, which is not till later, and then our parentheses, including absolute value, which was today's work. Okay, let's take a look at number 1. Sorry. Number 1 said to solve for x. I solve by x by isolating the variable, and I do it by SADMAP. I first subtract the b value over here, so I have 6 minus b, and then I divide off the m using my inverse operations, right? Inverse, the opposite operations. And when you get this down, that all you're doing is SAD mapping, it's not hard. You just have to follow the pattern, right? So on number 2, we're solving for k, this guy right here, right? So the first thing we have to do is, you could say this is evaluating the expression, because we need to address this 6 that it's being divided by. So we're going to multiply it to both sides. Then we can isolate the k by first SAD mapping, subtracting the 4 from both sides. And then we have negative k, but we can't have a negative k, so we divide by -1. Finally getting our answer that k is negative, sorry, there should be an x over here, bx, or 6x plus 4, right? And the same thing here. And then we write it correctly in the variable's perspective that we're solving for. K equals -6x plus 4. All right, number 3 asks us to solve for t, right? And this is the t value that we're looking at right here, because this is an addition sign, this one right there. So to isolate, we're going to subtract p from both sides, and then we divide off the PR to isolate our t value, and then we write it from the variable's perspective. T equals a subtract p divided by PR. On number 3, again, we're isolating, but we're solving for y. So we subtract 3x first, and then we divide by -4. And because we're dividing a negative divided by a negative, that's why this is positive right here. But if you left it as negative, it's okay. And then 12 divided by -4 is -3. On number 5, we have to evaluate the expression first, and that is why we distribute right here, getting 2a minus 2c. And we're solving for a over here, so we need to collect all of our a's on one side. I chose to move the 2a over with the 4a, and 4 minus 2 is 2a. And then I simply divide off this 2, getting my final answer. And negative 2 divided by 2 is negative 1. And that's why the answer to this is a equals negative c, or negative 1c, but it's just negative c. On number 6, it kind of looks a little crazy, but we're just solving for y on here. In order to solve for this y, I first must evaluate the expression in this layer right here, and that is why we distribute the a, giving me ax minus ay. Then I have to isolate this variable, so I first subtract the ax from both sides. So this looks a little tricky, but it's alphabetical. A comes first, so that's why it's negative ax first, then cx, and then minus d. Now we just have to divide off the negative a. And there's a couple of ways to do this. Keep in mind that when you're dividing off a, you're dividing it from here, and you're dividing it from here, and you're dividing it from here, right? It's dividing the whole thing. So if we isolate this out and say negative ax divided by a is just going to be positive 1. And on here, we leave it the same, and on here, we leave it the same, right? So you could just combine these two together because they have a common denominator, and just have cx minus d equals y. So we could write it y equals x plus cx minus d over negative a, or if we wanted to not do it this way where we separated it all out, we could just leave it like this, dividing the whole thing by a. That's completely fine. Number 7. I know it sounds really easy when I'm doing it, but we just need to get really comfortable with it, and we do that with practice. So here we are going to solve for x, right? But we see there's x's on both sides of the equations. So the first thing we need to do is evaluate our expression. And because it's divided by 6 over here, we're going to multiply both sides by 6. When I multiply both sides by 6, it has to multiply to distribute. And that's how I get 18a and negative 12x. Then this top number just stays the same. X minus 8a equals 18a minus 12x. Now I need to get all the x's on the same side. I chose to move this x over with the 12x, meaning that I have to move the negative 18a over with this negative 8a. Finally giving me negative 26a equals negative 13x. And it's starting to make sense, because when I divide this off, I know my answer is just 2a. Right? So I write it from the variable's perspective that I'm solving for, and so x equals 2a. On number 8, I get to just evaluate for x. And sometimes we throw in these easy ones towards the end because we know we're kind of getting tired here. So I'm going to go ahead and SADMAP, subtracting the 2a from both sides, giving me 9a, because 7a and 2a is 9a. And then I just simply divide off the 3, and I get x equals 3a. Number 9 goes back to something a little bit more tricky, where I first have to evaluate my expressions. So I'm going to distribute the 3, giving me 3bx, and 3 times negative 2 is negative 6ba. And then on the other side of the equation, I need to distribute a b, giving me bx, and that's here, and then negative 7ab. And then I still have this 3ab at the end. Now I want to combine like terms, right? Combine like terms. I'm still evaluating expressions. I'm combining like terms. Because I have negative 7a and positive 3a, that combines here to be negative 4ab, right? And now I finally am starting to isolate that x. So I'm going to move my x's onto one side, subtracting the bx over here to add with these bx, giving me 2bx. And I move over the 6ab onto the other side, and negative 4ab and 6ab is 2ab, right? Now I'm going to isolate my x. Now I could choose to do it one thing at a time over here. It's more simplistic. I divide by 2 first, and then I divide by b, getting x equals a. Or I could just simply divide by this 2b to both sides, and 2 and b will cancel out, leaving me a. So that means I have x equals a. Lastly, on number 10, we see this cross product that we have to do. Now, why can we do this cross product? Let me just back it up a minute. And in middle school, actually in like 4th and 5th grade, we learned that 1/2 of a cup is the same thing as 2/4, right? So let me just do this in the pizza world. If I have half of a pizza, that is the same thing if I cut that pizza into fourths that I have 2/4, right? We know they're equal. We can trust this equal sign. And because of that, we can do cross products. 2 times 2 and 4 times 1. 2 times 2 must equal 4 times 1 because it says it's equal. So we know it's 4 equals 4, which is true. So we can apply this to anything. So on this one, it says it's a fraction. I can do cross products here. And when I do this cross product, I'm simply distributing. I distribute the 9 to the x and to the negative b, giving me 9x and negative 9b. On the other side, I distribute the 2, giving me 4x and 6b. Now I get to put all of my variables, I finally get to solve, right? So now I'm SAD mapping. I am moving all of my variables onto the same side. I chose to move the 9x over with the 4x, right? And I use inverse operations because it's an equal sign. I'm not combining like terms. I am moving over the equal sign using my inverse. And on this side over here, I'm going to go ahead and move the b over with the b's. So negative 9b and negative 6b is a total of negative 15b, and negative 9x plus 4x is negative 5x. And now I finally get to isolate my variable b by dividing off negative 15. And I have negative 5x divided by negative 15. And I can reduce this fraction because negative 5 over negative 15 is the same thing as 1/3, right? A negative and a negative is a positive, right? So it's 1/3. And that's why b is equal to positive 1/3. And that's how we did 1/6 homework.